Okay, welcome to 10.5, which is a unit circle with trigonometric ratios. I've already worked out our bell work here. A couple things to note again when we're drawing our reference triangle on a coordinate axis. I give you your ordered pair. You want to find that first. From the point that you're given for your ordered pair, you're going to draw the radius or hypotenuse back to the origin. And your right angle will always be on the x-axis. It'll also be directly below the ordered pair I've given you or above it, depending on the orientation of that point. Calculate to use Pythagorean theorem to calculate the hypotenuse. -3 quantity squared plus 7 squared is equal to 58, so our hypotenuse is rad 58. And I've given you your sine, cosine, and tangent values. You can go check your work as well. So today we're going to work on 10.5, which is a unit circle with trigonometric ratios. We're going to find reference angles on the unit circle, and we're going to use reference angles to identify trigonometric ratios. So before we get started, we need to do a little bit of dividing fractions review. I've given us a problem here, 2/3 divided by 5/7. Of course, 3 out of 2 of you might struggle with this problem, so let's go ahead and do a quick refresher on it. When we divide by a fraction, it is the same as multiplying by the reciprocal of what we're dividing by. So instead of having 2/3 divided by 5/7, I can write this as 2/3 multiplied by 7/5. When I do this, I just take and multiply the numerators together, which is 2 times 7, which is equal to 14. Multiply the denominators together, 3 and 5, to get 15. So we get 14 over 15 as our answer. Hopefully that's a good refresher on dividing fractions. So here are the steps we're going to use in order to place a reference triangle on a coordinate axis, and then also find the trigonometric ratios for that reference angle. First thing you're going to do is find the reference angle you need. It's always going to be in relation to the x-axis. So we're basically always going to use numbers like 0, 180, and 360 degrees. Those are going to be for the x-axis. The next thing you do is you find the opposite and adjacent sides when your hypotenuse or your radius is 1. Because if we think about our unit circle here, with a radius of 1, anytime I draw a hypotenuse, that is the same as drawing a radius. And then finally, we're going to find all the ratios of the angles using our mnemonic or shortcut SOHCAHTOA, such that sine tells us the ratio of the side opposite to the hypotenuse. Cosine is a ratio of the length of the adjacent side to the length of the hypotenuse. And tangent is the ratio of the side opposite, or the length of the side opposite, to the adjacent side. So let's go ahead and dive right into our first example, and we're going to find all 3 trigonometric ratios of the given angle, 210 degrees. I'm going to start first by just labeling my axes, 0, 90, 180, and 270 degrees. This will help me pinpoint what quadrant the 210 degree angle goes in. And as I look at it, that's going to be in quadrant 3. When I think about quadrant 3, I know that both my x value and my y values are negative. Knowing that, I know my sine and my cosine are going to be negative as well. Okay, so what is my reference angle? Well, I'm going to take 210 and I'm going to subtract 180 from it, since my reference angle will go from the hypotenuse back to the 180 degree mark, or the x-axis. I can then complete my drawing of my triangle, the right angle on the x-axis away from the origin. Okay. Oh, I didn't actually come up with our reference angle, which is 30 degrees. Knowing now how my hypotenuse is 1, I then want to go and look at my 30, 60, 90 reference triangle. And if I remember there, my hypotenuse there was 2. the side opposite the 30-degree angle was 1, and the side opposite the 60-degree angle was rad 3. Well, I notice here that the reference angle on the unit circle has a hypotenuse of 1. My 30, 60, 90 triangle has a hypotenuse of 2. So I'm just going to half, 1/2 each of the lengths here. So in the reference angle, the side opposite 30 is just going to be 1/2. And the side opposite the 60-degree angle is going to be rad 3 over 2, which is half of rad 3. Now, since I know that this is in the third quadrant, both my values are negative, -3/2 and -1/2. And now I'm ready to determine my trigonometric ratios. My sine of 210, the sine is always the opposite over my hypotenuse. So I'm going to have -1/2 divided by 1, which is going to be obviously -1/2. My cosine of 210 degrees is going to be my adjacent side over the hypotenuse. Well, my adjacent side is -3/2. My hypotenuse is 1, so I end up with -3/2 over 1, which is equal to negative radical 3/2 as my cosine of theta, or cosine of 210 degrees. And finally, my tangent is just my adjacent side, or my opposite side, I should say, which is -1/2, over my adjacent sine of radical 3/2, negative radical 3/2. So in this case, we are going to have to divide by a fraction, which is the same as multiplying by its reciprocal. So -1/2 over negative rad 3 over 2 can be rewritten as 1/2 multiplied by 2 over radical 3. Now I crossed out the negative sign since I had a negative on the top and the bottom. I'm going to multiply these together, and I'm going to get 2 over 2 rad 3. I have a 2 in the numerator, 2 in the denominator, they cancel out. That leaves me with 1 over rad 3. To rationalize it, I multiply both the top and the bottom by rad 3, and I end up with my tangent of 210 degrees is the square root of 3 over 3. Okay, let's look at our second example. Now we're going to find all three trigonometric ratios of the given angle 135 degrees. So again, like the last problem, I'm going to start off with 0 on my x-axis, starting off here. Label this 90, 180, 270, and also 360 here. Sine of 135 degrees is going to go in quadrant 2. And in quadrant 2, my x values are negative, my y values are positive. My assumption, as I look at this, is that sine will be positive, cosine will be negative, and my tangent will also be negative. Okay, that being said, we're going to take a look at completing this reference angle and drawing its corresponding triangle. To do that, I need to take the reference angle, which is going to be between the hypotenuse, or the radius, and the x-axis. That means I'm going to take 180 and subtract 135 from it and end up with a 45-degree angle, which means I'm going to have a 45, 45, 90 triangle. Again, my hypotenuse, or radius, is 1, and I want to compare it to a typical 45, 45, 90 triangle. The nice thing about the 45, 45, 90 triangles is that both legs are the same length. In this case, we know that when a 45, 45, 90 triangle has a hypotenuse of rad 2, each leg is 1. So I'm going to figure out the legs of my reference angle of 135 degrees, the corresponding triangle to that. And I'm going to set up a ratio. The ratio of the hypotenuse on my reference angle versus the 45, 45, 90 triangle hypotenuse of rad 2. Then I'm going to take the ratio of the side opposites 45, which would be x for the reference angle, and would be 1 for the 45, 45, 90 triangle. This means my answer is going to be 1 over rad 2. Rationalizing my denominator, multiply by rad 2 on the top and the bottom, and I get rad 2 over 2. So the legs of both legs of this right triangle are rad 2 over 2. We know our x value is negative, so I'm going to get negative radical 2 over 2. And I'm actually going to do that in blue so you can see the difference here. And the other leg for our y value would be radical 2 over 2. Both the same measurement, one being negative due to its orientation. So sine here is opposite over adjacent, which means we're talking about our y value, by the way. So I'm going to get radical 2 over 2 divided by 1, which is simply going to be radical 2 over 2. My cosine of theta is adjacent over hypotenuse, which means I have negative radical 2 over 2 divided by 1. And that means my cosine of 135 degrees is negative radical 2 over 2. Finally, my tangent is just my my opposite, rad 2 over 2, divided by my adjacent, negative radical 2 over 2. When I look at this problem, if I see everything's on the top, same on the top and the bottom, that's typically equal to 1, except for I still have this negative sign here. So my tangent here is negative 1. So again, my sine of 135 degrees should be radical 2 over 2. My cosine of 135 degrees is negative radical 2 over 2. And my tangent is negative 1. That's mostly it for this lesson, except for we want to consider our trigonometric ratios and the values of them in quadrants 1, when they're in quadrant 2, when our reference angle's in quadrant 3, and when our reference angle's in quadrant 4. In quadrant 1, sine, cosine, and tangent of theta are all greater than 0. In quadrant 2, only sine is greater than 0. Both cosine and tangent are less than 0. In quadrant 3, only tangent of theta is greater than 0. Both sine of theta and cosine of theta in quadrant 3 are less than 0. Or 0 themselves, I should say. Finally, in quadrant 4, it is cosine of theta that is greater than 0. And it is there that my sine of theta and my tangent of theta are less than 0. Okay, that's today's lesson. Please finish up your homework for 10.5 and submit it. Work on any outstanding homework assignments you might have, those that need to get done before spring break, and please submit those. And I just have one simple request for you, and that is to have a happy spring break. Best of luck to you. I will see you back after spring break.